is applying the same things, but now we're going to look at the vertical axes. Up till now we've only talked about the horizontal, so now let's apply it to a vertical. And this is where we're going to use our force of tension that we talked about before. So, a person and an elevator have a combined mass of 6 times 10 to the 2 kilograms. So we think about them as one object. The elevator cable exerts a force of 6.5 times 10 to the 3 newtons up on the elevator. Find the acceleration of the person in the elevator. What can we assume about we're saying, so I should tell you this. We think about the person is in the elevator, so they are like one object. So we just look at their combined mass for this example. So for these questions, let's draw our free body diagram. So here is the elevator with the person inside of it, with our dot in the middle. We have Ft is our force of tension from the cable pulling, exerting a force upward. This is equal to positive 6,500 newtons. Yeah. Or you can write it in scientific notation. Doesn't matter. And opposing that is our Fg, our force of gravity. We're not given that in the question directly, but is there a way we can find it out? To start the question, how, Lewis? Well, this is on Earth, right? We're assuming this is on Earth, so I can use the formula Fg is equal to m times the acceleration due to gravity. So the force of natural gravity pulling the elevator down is going to be calculated using this formula. I know my mass is 600 kilograms, and my acceleration due to gravity is the constant of 9.81 times 10 to the power, or wait, 9.81, what am I talking about? Meters per second squared. Now, I'm going to set this to negative because I know my force of gravity is going down, and we need to reference it because this one's going up. I need my force of gravity to be negative. You could leave this as positive and calculate Fg and then just set it to negative. That's fine too. Just know that we need to set Fg equals to negative because it's the opposite force of the tension pulling it up. So our Fg is equal to negative 5,886 newtons. Okay, then we are asked to find our acceleration of our person. So I need to find my F net in order to do that. So my second step is that I need F net. Well, F net vertically, because this is all about vertical, or our y component, is equal to Ft plus Fg. So my F net then is positive 6,500 newtons plus negative 5,886 newtons. So F net is equal to positive 614 newtons, which makes sense because we're told that well, I guess we're not. But the elevator's going up. Yes, we are. It says the cable is pulling it up. So the force, the overall net force, needs to be in a positive direction for the actual cable, or for the actual elevator to be going up. Okay, now we do step 3. Because what I want to find is my acceleration. So since my F net is equal to 614 newtons, and my mass is equal to 600 kilograms, we are finding our A. A is equal to F net divided by M. So A is equal to 614 newtons divided by 600 kilograms. A is equal to 1.02 times, why am I going times 10 to everything? I taught the grade 10 scientific notation today, so maybe that's why. I think their minds imploded, but it's okay. Tell them it's okay. And I taught them sig digs too. I told them it was the most important thing that they'll ever learn in science class. Meters per second squared, what direction? Up. Well, it is, because you have to apply it to every science. You know, sig digs, so important. Okay, one more example. Can I erase this? Yeah? Okay, very same scenario, so we have to do the 3 steps again. So a 60 kilogram person standing in an elevator. As the elevator starts moving down though, the person feels lighter for a moment. If the elevator cable exerts a force of 550 newtons up, what is the acceleration of the elevator? Okay, so the first thing, we need to find out, well, no, wait, we should draw our free body diagram. I have Ft going up and Fg going down. I know my Ft is equal to positive 550 newtons. Right now I don't know my Fg, but I can find it. Fg is equal to m times by the acceleration due to gravity. Oh, I don't know the mass of my elevator.
I think those last phrases should be switched. There's 2 questions, if you know what I mean.
What is the acceleration of the person?
Yeah.
Yes.
So it's like the same question.
Same question, yes. Thank you. Okay, so our Fg is equal to 60 kilograms times by 9.81 meters per second squared. So it's negative 588.6 newtons. And I know my Ft is positive 550. So my second step now is that F net is equal to Fg plus Ft. So I have my FG is negative 588.6 newtons, and I add that to 550 newtons. My F net then is negative 38.6 newtons, which makes sense because I'm told in the question that the elevator is actually going down. So my net force should be a downward force. Now the third step is to find the acceleration using my F equals ma. So F net is equal to m times by a. So this is my mass, I was told, is 60 kilograms. My F net, I found out, was negative 38.6 newtons. To find a, I go F net divided by m. So A is equal to negative 0.6433 repeating meters per second squared. Do I need to scroll up a little bit? So I'm going to convert the negative into a direction. So my acceleration is 0.64, how many seconds? 2? Yep. Meters per second squared down.